Hi, I'm Kelsey Brennan-Wessels, and I'm here at the Living Planet Symposium in Edinburgh, and today I'm speaking with Volker Liebig, who is the Director of ESA's Earth Observation Programs, and with Alan O'Neill, who is the Chairman of ESA's Earth Science Advisory Committee. Now, for the next 2 days, there will be 2 sessions discussing the challenges that face the Earth observation community. Now, Volker, can you begin by telling me a bit about these challenges and how they'll affect the future strategy of ESA's Earth observation programs?
Well, we have defined a set of strategies, or our scientists have defined them some 7 years ago, and they were a guideline for us to implement our scientific Earth observation program. So now, after 7 years, we feel that it's time to renew them, bring them up to date. Many things have changed, and so we are looking forward to the discussions.
And how will these discussions affect the strategy?
Well, the challenges, as I said, they will be the skeleton, more or less, of the strategy, which we will then follow for the implementation.
Okay. Now to Alan, what are the main points that will be addressed during these next 2 days?
The main point really is that Earth observation is of fundamental importance to deal with the issues that we face on the planet. We've seen a number of long-term trends in population growth, demand for resources, pollution and climate change, and Earth observation is fundamental to dealing with those societal issues. So the overarching theme of what we're trying to do is identify the main scientific challenges that can respond to the needs of society, and that's the way I would encapsulate what we're trying to achieve. Now from that we have to drill down to say, well, given that overarching element, what does it mean to the very specific scientific priorities that we have to set in the various parts of the Earth system, the atmosphere, ocean, land, cryosphere, biosphere? And how do we design then the Earth observing systems and instruments to deliver that science? And that's what we're going to do. We're going to start with this top-down view of the overarching imperative for societal benefit from Earth observation, and then find out scientifically how we need to deliver and respond to that.
Now, of course, as Alan mentioned, we're looking at these challenges that face society on a whole. Can you start by talking a bit about the major international concerns, such as food supply, water security, these sorts of things?
Well, in the 21st century, we are facing especially a strong increase in population. We have at the moment 7 billion people on this planet, but in 2040 already 9 billion are expected. This will lead to changes. This will lead also to pressure on the environment. We need to feed these people, and FAO has estimated that to feed 9 billion people, we need to increase our food supply by 70%, for example. We need to have enough water available. Much of this population growth will be in megacities. We will have an increase of the number of megacities, and we will have all the effects which are coming to environment, for energy, for pollution from these mega agglomerations. So these are new developments which we have to tackle with. I think Earth observation must help to find solutions to these societal challenges, and these are some of the factors we are going to discuss.
Okay, great. Now, Alan, of course, we're also going to be discussing the water, energy cycles, heat, mass transport. Can you comment a bit on the challenges that face us in those areas? I'm going to pass this over to you.
These are very, very profound challenges, and the real challenge actually is that to respond to the science put in the way you've just done it, the large-scale cycles of water, energy and mass, it needs a much more integrated approach, because the individual observations are vital, but they're part of the puzzle, and we need to integrate a range of observations. And we've seen that beautifully here already at the Living Planet Symposium with GOCHE, SMOS and Cryosat, and they are exemplars of how we need to do science in the future. And if we're going to deal with these complex cycles, which we really don't understand very well, then we have to get this integrated approach in terms of our observations. The other point I would make is we need high quality data. So it's not just a question of acquiring the data, that's fundamental, and building the technology. It's the advanced methods of data processing, calibration and validation that will be essential, especially if we want to understand any long-term trends and attribute those trends, for example, to human activity.
Now, what about, I'm going to say with you, what it's in the area of non-man-made disasters, natural hazards, how are we going to address those?
Yes, there are so many of them actually. They come in a variety of guises. Of course, we have earthquakes, we have volcanoes, we have intense and extreme weather, and we have pollution. I think the point I made earlier on about the integrated observing suite, if you like, is fundamental to in these areas as well. But I would add another element. Of course, if we're dealing with natural disasters, these disasters cannot come upon us by surprise. We need timely delivery of data. We need advanced ways to disseminate the data. In some cases, we need to develop better predictive systems. For example, if we're dealing with extreme weather events, we need to improve our models. And this is where Earth observation also is fundamentally important, both to assimilate the data into the models to provide the initial conditions to make the forecasts, but also to improve the models for prediction. There are some areas where the prediction is less than perfect and may never be that good. Earthquakes are an example, but Earth observation is fundamental there because we can now monitor the build-up of stress and strain on the surface of the Earth and thereby assess the risk. So yet again, Earth observation is key to dealing with these natural hazards.
Now, of course, we have about almost 2,000 participants here at this symposium. Can you comment a bit about comment on the importance of maintaining a dialogue with the scientific community? I understand that for the next 2 days, you will be speaking with the scientists about these particular challenges. Why is it important to speak to them face to face?
Well, it's obvious. We want to have a science strategy which is building on many opinions, not just on some. We have already based the draft on 50 scientists and interviews with scientists and on the opinion of the ESAC, of the Science Advisory Committee. And now we go into the scientific public, an event like this, where we have the biggest science gathering probably of the year in Earth observation. This is a unique chance, once in 3 years, so we had to use it, and this is what we do.
Well, Volker and Alan, thank you so much for joining us today. And to our viewers, remember that to follow all the events going on here at the Living Planet Symposium in Edinburgh, you can watch us at www.isa.int.